All right, so I'm not sure what's happening with everybody else, but I'm going to get started. You'll notice that in the video, in the Teams, there is two recordings there, Pythagoras theorem, trigonometric ratio. One of the next topic that we have to look at is angles of elevation and depression, sine and cosine rule, and bearings. We're going to see how much we can cover today, because once we are done with that, that means that we would have covered all of module 2, right? So you notice, let me just bring it on screen, see if I can. No, it's not up. Let me just bring it up on screen so you can see it. All right, so Pythagoras theorem, trig ratios. Then you have sine and cosine rule, angles of elevation and depression, bearings. That would have all covered module 3. We look at statistics already. We look at the frequency table, and we look at ungroup distribution. We looked at group distribution. We look at how to get a class interval. What we didn't do is the whole business of pie chart and bar graph, because persons didn't have graph paper. We also did probability already. So we basically we did almost all the objectives in module 4. So one of the things that we'd have to do in terms of pie chart and bar graph and line graph is just to do, as you would have seen in your group, a recording on it so that you can, finish up the content. So what we are going to do today, we're going to be looking at angles of elevation and depression, sine and cosine rule, and see how much we can cover in bearings. Now, geometry, if you notice, geometry is 2 classes. This is the only module that we would have not done any lessons on so far, because we did module 1 while we were at school, area of triangles and those type of things. So the reality of it is, there are some videos that you're going to get, which you have to watch to catch up on it. All right. You'd have seen all the back and forth with the course in terms of whether the course is going to be offered or not, and all the different things that would have impacted us having classes. So one of the things that is going to be necessarily important is us doing the assignments, and it works already. 60% for the assignments, 40% for the exam. So we need to get a very good assignment done. So what I'm going to do, as I mentioned earlier, I'm going to put the assignment in the Teams, because from what I know, Moodle is down, because the assignments were supposed to be offered on Moodle. But Moodle is down, so I'll just post the assignment in the Teams so you can just go ahead and get them done. All right. And as I mentioned earlier, we can just look at a May deadline for the assignments. All right, angles of elevation has to do with trigonometry in terms of sine, cos, and tan, but primarily you are going to be using tan primarily. But it is not to say that you can't be asked to use any of the other trig ratios. So what I'm going to do, I'm going to look at a few questions that have to do with the diagrams, and then we look at a few questions that have to do with worded problems, and then we take it from there. I'm trying to remember where I adapted this worksheet from, but I'll check in a bit to see so that I can let you know where this worksheet came from. But I saw this worksheet advertised online. It looked good, so I just copied it for the purpose of our class, but I did not create it myself. All right. Based on this question, it says a kite with a string of 150 feet long makes an angle of 45 degrees with the ground. Assuming this the string is straight, how high is the kite? So the height of the kite is the same thing as the altitude of the kite. So notice what is happening here. This altitude or this height would be a perpendicular height. And based on this box right here, which indicate that we have a right angle triangle, this side over here is going to be the hypotenuse, and this side over here is going to be the opposite to the angle. So based on this, we know we have the opposite and we have the hypotenuse. Now, the ratio that deals with opposite and hypotenuse is sine. This side would be the adjacent, but we are not given any information about the adjacent, so we can't use any of the ratios that uses adjacent. So please bear in mind, if you have sine of theta is equal to the opposite side over the hypotenuse, using all the space. If you have cos of theta, it's going to be equal to the adjacent side over the hypotenuse. And if you have tan of theta is equal to the opposite side over the adjacent. All right. So these are the ratios we are working with. So based on what we have, we're going to have to use the sine because there is no adjacent. We're not asked to find it and we're not given the length of it. So it's going to be sine of the angle, which is 45 degrees, is equal to the opposite side, which is x, over the hypotenuse, which is 150. Now, what we can do is that we can make this side into a fraction. And we know that if you have one fraction on either side of the equal sign, you can cross multiply. This means that 1 times x is going to equal to x, and we're going to have 150 times the sine of 45 degrees. Now, all you have to do is just plug this information in your calculator. 150 times the sine of 45, that's going to give us that x is equal to 106.07, and the unit is feet. So that's what we would get for the answer for that question. If you have any queries, you can go ahead at this time before we move to the next question.
Oh, sir. Sir, my mic not work.
No, sir.
Yeah, mic not work. Yeah, that's why I use my.
Okay, okay. All right, so once there is no question, that's fine. You can let me know when I can move on. What I'm going to do is that this document, I'll just upload it in the Teams afterwards so you can have access to it.
You know, I'm not up the assignment there, so I'm not too sure about that exam, you know.
Yeah, man, as I mentioned to you, you just have to just, you know.
But the truth, sir, if I would just say, the other questions, them say, be assignment, me I do.
Yeah, that's why I'm telling you that I'm not asking you guys for the assignment in this month. I'm giving you until in May to get it submitted, so that you know you guys not under pressure while you're doing your exams. That's what I'm saying. So exams are finished the end of April. So all you do, based on how you know you go and do your exam, you know, so you have to focus in the coursework, submit your assignment them online so we can have access to them to mark them and make you get your grade. We know it go already. you can do well in the assignments, and that can give you a good grade to pass the pass the course. So make we focus in on that area. No?
Yes,
All right.
sir. Basically, I'm mostly assignment the more focus on that. The exam thing, sir. No, no. When I go in the exam, them say, "Sir, my brain just fry." So I just want the assignment them I know, say, I pass the course,
Yeah,
and
yeah.
exam knowing say I already pass already. So I just do what I can do for the exam, basically.
Oh, understood. Mine is a mental block you develop still, you know. So want to find the
Yeah,
angle, right? So it says, um, so what we want to recognize is that the angle of elevation to the sun, right, is x right here. So we need to find out what is going to be the angle of elevation to the sun. So we are minded that the tree casts a shadow that is 17.3 meters long. So based on this shape, this is the angle, this is the opposite side, and this is the adjacent side. The ratio that deals with opposite and adjacent is tan. So it's going to be tan of the angle x is equal to the opposite side over the adjacent side. So we want to find x as I indicate over here. So to find an angle, the size of an angle or the magnitude. So if you see they use the word um, um, magnitude or size, it's still the same thing. So to find the size of an angle, you have to use the inverse of the trig function. So it's going to be tan inverse 17.3. So it's going to be tan inverse of 10 all divided by 17.3, which is going to give you an angle of approximately 30 degrees. So the angle x is going to approximately be equal to 30 degrees. Now, normally we round off an angle to, once it's a decimal angle, to one decimal place, but the decimal point that comes after this is 0.29, which would not, so we'd round it up to 0. So it wouldn't impact the answer. So we just approximate it to a whole number. So it is not exactly 30, but we just approximate it to 30. All right, question number 3. So airplane is flying at an altitude. Altitude is the same as the height, right? And it's the perpendicular height, right? Once you're talking about the altitude, it's a perpendicular height. 12,000 meters from the pilot. From the pilot, the angle of depression to the airport is 32 degrees. How far is the tower from a point directly beneath the plane? So we want to find this distance here because as it is denoted on the diagram. So this angle and this angle here is going to be the same. So we need to know that an angle of elevation is equal to the angle of depression because they form what is known as alternate angles. All right, so they form what are called alternate angles. So we know that they are going to be equal. So based on this angle, this side over here is the opposite side, and this side down here is going to be the adjacent side. So it's using a tan again. So tan of 32 degrees is going to be equal to the opposite side, which is 12,000 divided by x. Cross multiply. X times tan 32 is going to give us x times tan of 32 degrees is equal to 1 times 12,000, gives us 12,000. I want x alone, so I'm going to divide by tan 32 degrees, divide by tan 32 degrees. So this implies that x is equal to 12,000 divided by tan 32 is going to give us 19,204.01 meters. So that is how far the plane is from the tower on the horizontal ground. So this is the distance on the ground that the plane is from the tower. All right. All right, let's continue. As I mentioned to you, the document will be shared so that we have access to it. So I'm not going to be necessarily doing all of them because what is possibly true is that when you get the document, you can choose to work out a few questions as well. So I'm not going to be working out all of them. I just want to see. All right, so I'm going to be working out number 8, and I'm going to be working out number 10. And then I'm going to do some of the worded problem questions. So that's 8 and 10. Because all the others are similar, you just identify where is the opposite, where is the hypotenuse, where is the adjacent, and then you just solve from there. All right, so based on this, it says we need to find the angle of depression of the boat to the shark. So we need to find this angle here. So based on this angle, this side is the opposite side. And this side over here is going to be the hypotenuse. All right. So if you have an opposite and an hypotenuse, you're going to be using sine. So sine of x is equal to the opposite side, which is 22 divided by the hypotenuse, 67.7. Sorry. So to find x is going to be equal to the inverse of the trig function, which is 22 divided by 67.7. So that means x is going to be equal to sine inverse. So you press shift or second function and then the sine button, 22 all divided by 67.7. And I'm going to end up with an angle of 18 point, well, it's 96. So it is, the angle is approximately equal to 19 degrees. All right. because as I mentioned, we normally round off to one decimal place, and based on this one decimal place, the 6 will round it up, and then it will eventually round up to 8 to give you 90. Let me just see if anybody else joining. Anybody else joining us? So even bear in mind, even when it comes down to the assignments, you have to have some amount of notes or knowledge where you can do your work. So you have to have the notes by which you can use it to look back at to answer the questions. So that is going to still become important. All right, let's continue. I said I was going to do number 10 as well. A bird is flying at a height of 40 feet and spot a 8 feet ledge on which to perch. If the top of the ledge is 22 degrees angle of depression from the bird, how far must the bird fly before it can land? Carefully. Now, if the bird is going to perch, right? This is the distance. Notice they identify the distance here as x. So that's the distance the bird must fly. So one of the things that we're going to do is this. I can complete the shape at this end to make a triangle. So right here, I would have the right angle. So this would be my hypotenuse. Now, please note that the total height of the bird is 40 and the total height of the ledge is 8. So that means this distance right here is going to be 32 feet, because this 32 feet plus this 8 feet must give you a total of 40 feet. All right. So based on this shape, we have this side over here to the angle, which is the opposite, and you want to find the hypotenuse. So which ratio we use with opposite and hypotenuse? That's going to be sine. So sine of the angle, which is 22 degrees, is going to be equal to the opposite side over the hypotenuse. So x times sine 22 degrees is equal to 32. I'm solving for x. I need to divide by sine 22, divide by sine 22. So this means that x is going to be equal to 32 divided by sine of 22. So I end up with a total distance of 85.4 feet. So that's how far the bird must fly in order to perch on that ledge safely. All right. So in order for the bird to land on this perch safely, the bird must fly a total distance of 85, approximate distance, I should say, of 85.4 feet. All right. So we're going to be looking at some of the worded questions now and how to get the diagram and solve the question from the worded question. All right, let's look at the worded problems. So again, like with the first question, we're not going to be able to do all of them. Let me just see if there's any with two angles yet. So maybe like this one or this one. Master already. All right, so these down here, they have two. All right, so from the language of the question, it can brings us back to what we did in the previous question above. It says, Brian kite is flying above a field at the end of a 65-meter string. The angle of elevation to the kite measures 70 degrees. How high is the kite above Brian's head? So Brian would be somewhere here. This is the horizontal ground, and this is him. This is the kite. So the kite is somewhere here. All right. So this is Brian. So Brian can't be both flying the kite and the kite is over his physical head at the same time. All right. Because you notice we don't fly kite vertically up. The kite is based on the wind acting upon it, the kite would be some distance away from us. So the string is a 65-meter string and the angle of elevation, which means that when Brian is looking up at the kite, he will get an angle of elevation of 70 degrees. How high is the kite above Brian's head? So we need to know this distance. Based on this shape, this is going to be the opposite side. And this side over here, which is the string, is going to be the hypotenuse. So sine of 70 degrees is going to be equal to the opposite over the hypotenuse. And if we are solving for x, 1 times x is equal to x, and then we're going to get 65 times the sine of 70 degrees. So this is as a calculator working out 65 times sine of 70, and we end up with x is equal to 61.08 meters. Now, one of the things that I want to caution you on is that once you're solving questions that is a worded problem, always use a diagram to represent what is what you're calculating. Sometimes, these questions are given a mark, even sometimes it is not clearly stated in the question. And that's why, for the most part, we try to encourage that, whoever is setting a question paper needs to clearly identify where the mark should be allocated. So if there's going to be a mark for a diagram, you must say, represent the information on a diagram, right? Because if you're not being marked for it, then the impression would be, oh, you don't need to do it. So that's how most people sometimes lose marks and don't even recognize that they were marked for it in the first place. All right. All right, this one has to do with the plane. It's basically as the one we did earlier, same as with number 1, from the top of a this is the same question from a point on the ground. So this is the flagpole. The angle of elevation measures 53 degrees, and the distance is 12 feet from the foot of the flagpole, right? So it says how tall is the flagpole, which is the opposite side based on the angle, and the 12 feet is going to be the adjacent side. So based on this, if you have opposite and adjacent, you're dealing with tan. So tan of the angle, which is 53 degrees, is equal to the opposite side. You can just write flagpole if you want, all divided by 12. 1 times flagpole is just going to give us flagpole equals to 12 times the tan of 53 degrees. So 12 times tan 53 degrees is going to be equal, gives us that the flagpole is equal to approximately 15.92 feet. So that's how tall the flagpole is, right? And as you notice, these questions pretty manageable in terms of once you get the diagram and know to identify where is the opposite, where is the hypotenuse, where is the adjacent, then it should be manageable to work out in terms of working to get to your final answer. Okay, continuing. Looking for an angle of depression. This one is an angle of elevation. All right, this one is an angle of depression. And this one is an angle of elevation. So I'm going to do these two questions, and then we're going to look at the sine and cosine. So doing these two questions, then we're moving on to the sine and cosine. So from a plane flying due east, 265 meters above sea level, the angle of depression to two ships sailing due east measure 35 degrees and 25 degrees respectively. How far apart are the ships, right? So here's the plane. So we're going to say that this is a plane, altitude, and so we're going to say these are the two ships. We're going to call this ship 1 and ship 2. 90 degrees, distance is 265 meters. Now, how do we get the angle of elevation? So this is you looking directly in front of you. So your angle of depression, when you look down, the first ship that you're going to see is ship 1 here, right? So that's the first one you're going to see. The first angle is always going to be the smallest. Reason being, think about it. See, this is you. Naturally, when we're looking, we look out in front of us. Now, if we see if there's an object here, an object here, an object here, and an object closer to us, when you're looking to look down at your feet, you're going to see further out first, and then you start to looking a little closer, looking a little closer, and then till you tilt your head, till your head is all the way looking down. So you would have tilt your head through an angle of 90 degrees. So the one that is furthest is always going to be the angle that is the smallest, because even sometimes just by tilting your eyes, you can see certain things that are out in front of you without moving your head. All right. So this first angle is going to be the 25 degrees, which means that right here is also 25 degrees because the angle of depression is equal to the angle of elevation. And then when to look to see the second ship is going to be this one right here, and it's going to be this angle, which is 35 degrees. So that means this angle is 35 degrees as well. All right. So the angle of depression is formed from the line of sight. So this is your line of sight. Yeah, looking out in front of you. And then when you change the line of sight to look down. So this is the line of sight looking down, the line of sight looking down. All right, so that's how you get the angle of depression. So let's look at what we're working with in terms of working out this question. You'd bear in mind that it says it wants a distance between the two ships. So I'm going to call this distance x, and then this distance here, I'm going to call y. So the distance from a point directly below the plane to the first ship, to ship 2, I'm going to call that distance y. And a ship all the way to the distance between the two ships, I'm going to call x. All right. Now, please note, there is also another distance that we can factor in, which is the entire distance from a point below the plane all the way to ship 1. We could even call that point M. All right. Well, not point, that distance M. So here's what we're going to do. We're going to separate the shape into 2 right angle triangles. So from ship 2, base of the plane 265, plane. Base of the plane, ship 1, 25 degrees, plane 265. Right. Now, this one is 35 degrees. So based on this, we can do a calculation. We can find this distance here, yeah, which we had indicated to be y. And we can find this entire distance from ship 1 to the base, which we consider to be m. So to find x, it's going to be equal to m minus y, all right? Because if we know all of m and we know y alone, if we subtract y from m, we're going to be left with the distance, which is x. So let's go and find y. Based on the shape, we are using tan, which is going to be tan of the angle 35 is equal to the opposite side, which is 265, all divided by the adjacent. Y times tan 35 is equal to 265 divided by tan 35 divided by tan 35. So that means y is equal to approximately, so that's 265 divided by the tan of 35, which is going to give me 378.46. And that is in meters. And we're going to do the same thing to find m. So it is going to be tan of 25 degrees is equal to 265 all divided by m. Cross multiply. So m times tan 25 degrees is equal to 265 divided by the tan of 25 degrees divided by tan 25 degrees. So that means m is equal to 265 divided by the tan of 25, 568.29. So x is going to be equal to 568.29 minus 378.46. So that means the distance between the two aircrafts, so 568.29 minus 378.46, 189.83 meters. So that's the distance between the two ships. Now, I know we did a lot there. So if there is any part of it that you're not sure about and you need me to clarify before we continue, you can just go ahead and let me know. All right, if not, I'm just going to give you a few minutes to make an attempt at question 7, and then we check on it to see if we're on the same track. So take a few minutes, look at question number 7, and then I see what you come up with to see if we're on the same track. Excuse me a brief moment. Yeah, man, go ahead.
Say I see a man say me I get back, but a different way me drive.
Well, because it says that they are on opposite side, we would have to reflect that opposite nature because we couldn't draw it like when both of them are on the same side, like the ship right here, ship one and ship two. Right? So that's only the difference that we would have to pay attention to. So this would be the distance that is between them. All right. So this will be available to you in the team. So what I'm going to be looking at now is the sine and cosine. Let me just give me a second and bring that up for you. All right, so we're going to be using this worksheet. We're adapting this worksheet from just 4-bit maths, right? So they normally do excellent worksheets, and sometimes, I would use some of the questions that they produce. So you can check them out when you need, if you need examples to practice from and stuff like that. So I normally, as I mentioned, use some of the questions from worksheets that they produce. Now, the sine and cosine rule is necessary for instances when we don't have a right angle triangle. All right. So if you're not working with a right angle triangle, you still need to know how to do the calculation. Now, this normally happens, as I mentioned, if you have a non-right angle triangle. This side is A, B, and C. Then opposite to the angle, the side is labeled with the lowercase letter. So that's why here, it is the length of the side over the sine of the angle, right? So you have length of side over sine of the angle. And then for the cosine rule, so notice A is the length of the side, and right here we have the cos or the cosine of the angle. So any side you start with, you have to end with the angle that is opposite to that side. So notice we start with side A, but we end with angle A. So if you start with side B, you have to end with angle B. If you start with side C, you have to end with angle C. So any side you start with, you have to end with the side, the angle that is opposite to that side. All right, let's look at this, please. One of the things that we always do is to help people to understand, oh, I should also bear in mind the trig rule for area. Area is equal to half AB sine C, and then you have Aaron's formula. So S is equal to A plus B plus C, all divided by 2. And then the area is equal to S, S minus A, S minus B, S minus C. So S is what we call the semi-perimeter. All right. So these formulas are used when you're calculating area. So we're going to look at when to use them, right? Based on the question that we're working with. All right. So based on this, that's angle C. This is side C. So based on this diagram, right? When you're going to be using the cosine rule, all right? When do you use the cosine rule? Let's look at this. Sorry. One, you have all three sides or slash the lengths, or you're given two sides and the angle between. So you're either given two sides and the angle between the two sides. So that's when you use the cosine rule. If you don't have those conditions, you have to use the sine rule. So if we look at question number 1, we're not given the length of all three sides. We're only given the length of one side. So that also eliminates number 2 because it says you must be given two sides. So we are only given one side. So that automatically eliminates the cosine rule because you either must have all three sides or two sides. So we have none of that. So we have to use the sine rule. So it is going to be A over the sine of A. Angle A is 33 degrees equal to B, which is 15 over the sine of 112 equal to C over the sine of C. Can't use because there we know nothing here. We don't know the length of the side. We don't know the angle. Yes, we can find the angle because you know the sum of the angles in a triangle equals to 180 degrees. So right here we have 145 degrees. So that means the remaining angle here must be 35 degrees. So angle C must be 35. Even though it's not given, but since you're given two angles, you can find the next one. All right, so let's go. It says that we are to work out the length of BC, and BC, in other words, is the same side as A. So we can use these two fractions. Every time you're using the sine rule, you can only use two of the fractions. So we can cross multiply. So we're going to have A times the sine of 112 equal to 15 times the sine of 32 degrees. I'm solving for A, so I divide by sine of 112, divide by sine of 112. This goes, so now A is equal to, all of this I can just work out on my calculator. So I'm going to say 15 times the sine of 33, and then I'm going to divide my answer by the sine of 112. So I'm going to end up with approximately 8.81 centimeters for the length of A. So that means, so we can say therefore, BC is equal to 8.81 centimeters because notice the axis of BC. So you have to solve for BC. So notice we know that A and BC is the same length. So all you have to do is just state that. All right. All right, should we finish writing? Let's continue. No, let me just add to this. One of the things that we could have done is to go on ahead and calculate the area. So we know that angle C is equal to 35 degrees. So we know that this length here is 8.81. So we use Aaron's formula when we have all three sides. If we don't have all three sides, we use the trig rule. And the trig rule is when you have two sides and the angle between. So the trigonometric rule for calculating area is when you have two sides and the angle between. So notice here, this side, which is B, we would know that side to be 15. This side, which is BC, we know that side to be 8.81. And the angle between is going to give us 35. So based on that, we could go ahead and calculate the area. So the area is equal to half. A and B is just going to be the two sides that you have, and you can write them in any order. The order doesn't matter. Times the sine of the angle, which is the sine of 35. So you can just do it all in one on your calculator. So sine of 35 times 8.81 times 15 divided by 2. So you get that the area is equal to 37.90, and this is in centimeters squared. So that is how you could go about working out the area, because you know this side, and the angle between the two sides. All right. So that wasn't asking the question, but I just expound on what they asked us for the question. All right, let's continue. For this one here, very easy to identify. You have two sides and the angle between the two sides, and it asks you to calculate the area of the triangle. So the area is going to be equal to half the two sides, which is 6 times 7, times the angle between, which is going to be the sine of 60 degrees. So you can just go ahead and substitute everything into your calculator, work it out all in one. So it is going to be the sine of 60 times 7 times 6 divided by 2. So we end up with that the area is approximately equal to 18.19, and this is in centimeters squared. So notice here, this side we know, this side we know the length, and where the two sides meet, we know the angle as well. So that's what it means by two sides and the angle between the two sides. All right. So that's how we calculate the area. All right, take off that one, please, and then we look at some other questions. Notice we want the size of angle ABC. So because B is the one in the middle, that's where the angle is. Now bear in mind, to use the cosine rule, you'd have to have all three sides or two sides and the angle between. So we were not given the angle between here, which is it would be this one. So we're not using the cosine rule, we're going to use the sine rule. So this is B, it's A, that's C. So A is going to be 18 over the sine of angle A, which is 60, equals to B, which is 20 over the sine of angle B, which is what we want to find, equal to C, which we don't know, over the sine of C, which we don't know and would not be able to find because we have two unknowns in the angle. So this one we're not using any at all because it has two unknowns. So we're going to have 18 times the sine of B, which is going to be equal to 20 times the sine of 60. Divide by 18, divide by 18. So sine of B is going to be equal to 20 times sine 60. Divide by 18. So we end up with 0.962. So remember, if you're finding an angle, you have to use the inverse of the trig function. So B is going to be equal to sine inverse of 0.962. The sine inverse of 0.962, that's going to give us approximately 74.2 degrees, which is the angle round off to 1 decimal place. So with that, if you want, you could go ahead and find the area as well. But since they never asked for it, for this one, we're not going to work it out. We're just going to move on to another question. So for this one, I want you to do two things. I want you to, as they say, calculate the length of BC, which is the cosine rule, and you're going to calculate the area of this shape, which is the trigonometric point. Go ahead and try this one, please.
Say the answer is 20.0 centimeter.
Go again.
The answer when I do my complete work, 20.0 centimeters.
For BC,
Yes, sir.
oh, I'm not sure as it. That's why
Okay,
I'm
sir.
just doing it. Sorry.
Yes, sir.
So that's what you said. 20.02.
20.0.
Huh?
You take off the two, sir. And that's why I'm rounding up to one decimal.
Okay.
Yes, sir.
Now, sometimes if you're given a shape and there's no label, you can go ahead and label it if you want. So we know that this side is small a, this side is small b, this side is small c. So 32.4 over the sine of 84 is equal to b over sine b equal to c, or the sine of angle c. But we know that it is going to be y. Can't use this one. So it's going to be 32.4 over sine of 84, 21 over sine y, 32.4 times sine y is equal to 21 times sine of 84. Sine of y is equal to, when we divide that, 21 times sine of 84, get approximately 0.66, sorry, 645 645. So y is going to be equal to sine inverse of 0.645. So we're going to get that angle y is approximately equal to 40.2 degrees. And looking for one of them that we have to use the cos rule to find an angle. All of them so far. Okay, here we go. So we want angle Z. So we want this angle here. So this side is common Z. This side is common Y. This side is common X. So what we're going to have is that because we want angle Z, we have to start with side Z. All right. So what we're going to end up with is 17 squared is equal to 22 squared plus 20 squared minus 2 times 22 times 20 cos of angle Z. So we're going to get 289, 84, so this is 884 minus 880 cos of Z. So we're solving for cos of Z. So it's going to be 289 minus 884 equal to negative 880 cos of Z. Negative 595 is equal to negative 880 cos of Z. Divide by negative 880. Divide by negative 880. Negative divide by negative give you a positive. So we're going to end up with 0.676 is equal to cos of Z. But I want Z alone. So Z is going to be equal to cos inverse of 0.676. So cos inverse of 0.676, that's going to give us that z, or angle xzy, is approximately equal to 47.47, well, 47.5 degrees, rounded off to one decimal place. Now, one of the things that I'm going to do as well with this question is to use Aaron's formula to calculate the area to show you how that is done using Aaron's formula. All right, so let's write that off quickly and then we look at it. All right, let's look at the Aaron's formula to see how it works when we are using it to calculate area. So once you have all three sides, which is A, B, and C, which is in this case X, Y, and Z, the semi-perimeter is going to be adding all the lengths and divide by 2. All right? So the semi-perimeter is going to be equal to 29.5. So the area is going to be equal to S times S minus A times S minus B times S minus C. So it's going to be 29.5 times 29.5 minus 17, 29.5 minus 22, 29.5 minus 20. So we're going to have 29.5 times 12.5 7.5 9.5. So when we take in the square root of the product of each of these times 7.5 times 9.5 times 29.5. So when we multiply all of them, we end up with 26, 2, 273.44. So the area is going to be the square root. So the area is going to be equal to the root of 26, 273.44, which is going to give us approximately 162.09, and it is in centimeters squared. So that is how you would use Aaron's formula to calculate the area. All right, so we look at how to use the formulas to calculate both angles, length of sides, and we look at how to use the trig formula, Aaron's formula to calculate area. All right. So I'm going to ask you to try one for yourself. When it says calculate the smallest angle in the triangle, the smallest angle is always opposite to the smallest side. So the smallest side is 9. So the smallest angle is going to be this angle over here. And remember, you can always label your diagram. So A, B, and C. So even though it is not labeled, you can label it. So the smallest angle is going to be angle C. So I want you to go ahead and find the area of this triangle and also the size of this angle right here, as is indicated by the question.
Okay, sir. So, so for the angle, it's 31.6 degrees, and for the area, I have 58.0 centimeter square.
You said 57.6 for the area.
For the area, 58, sir, point zero.
Okay. What did you have in the square root right here?
Which one?
Under the square root to find the area, what did you have? What number did you have?
For the area, oh, 110.5 times 0.5,
One,
525.
no, the final number that you took the square root of, what was that number?
What may I have sign you mean, sir?
Go
A
again?
half, sir, for area, a half, 13 in bracket, 17 in bracket, sign
Oh,
31.
that rule you use. Okay, I understand now. I understand. I use the errands formula. So notice the answers are still close, but I understand why you get that answer now.
Okay, sir. So for few one, you would have to round off. You get that same answer, right?
Yeah, you could round off this and get that same answer, but what happens is that when we are taking into account the method that you use,
Yes, sir.
there wouldn't be any penalty for your answer.
Oh,
Yeah, so it's not like, oh, yours wrong, mine right, or mine wrong, yours right. Based on the methods, there are some differences and the rounding off and all of that that will impact the answer.
okay, sir.
So this is telling us that C is going to be equal to cos inverse of 0.853, and we get that the angle is approximately equal to 31.5 degrees. You get 31 point something for your angle as well?
Yes, sir, 31.6.
Okay, so we're not too far off from each other. All right, so I'm gonna save this and then we look at bearings. All right, so for the purpose of this concept, there is this worksheet that I saw. And we're just going to use the questions from this to explore the concept. All right, so this worksheet was not one that was prepared by me. I got it from this site. So if you can choose to check them out for the questions and for other questions that they have dealing with other topics. All right, so bearings. Bearings is a way of telling direction. Let me just make a note of something. So bearings is used to tell direction measured from the north in a clockwise direction and using 3 digits. So it's always using 3 digits, all right? So a bearing is a way of telling direction measured from the north in a clockwise direction using 3 digits. Now, one of the things that we want to help people to understand or help persons to understand when we're talking about bearings and how we have to look at somebody. Now, take for instance, this is me and this is you. Now, if I'm going to look at you, let me just draw this down a little bit low. If I'm going to look at you, I have to first know where my north is. And this is me and you are right here. And then say for instance, you're calling to me. Say, all right, say for instance, we're walking, going down the road. This is the road. Yeah. Walking, going down the road. That direction, both of us walking, going down the road. Our intention is to get to school. All right. And you see me along the way, but I'm on the next side of the road and you call to me. Now, for me to look at you, this is me going down the road. I have to turn my head all the way around until I'm looking at you. So this is my bearing, right? It's in a clockwise direction measured from the north. But here's your problem now. You are walking going down the road the same way. And if you need to look at me, you have to turn your head all the way around in this direction to look at me. Why? Because the bearing must measure from the north and go in a clockwise direction. So you can't turn your head this way to look at me. You can't do that. Even though I'm in this direction right over here in front of you, you can't just look at me like that. Because you must bear in mind the rule. It is measured from your north in a clockwise direction using 3 digits. I mean, the 3 digits doesn't have anything to do with the direction, but in terms of what we're talking about now, how we're going to look at each other. So we have to bear in mind when we're thinking about bearing, how do we turn our head to look at somebody or to look at something or to find the direction between two things. It must be measured from the north in a clockwise direction. All right. Now, here we go. Let's look at what this is dealing with. It says the diagram shows the position of two churches, A and B, right? So we clearly see A and B. Amber says the bearing of church B from church A is 025 degrees. Amber is wrong. Explain why. Let's explain why Amber is wrong. And then one of the things that I'm going to make note of here, bearing is always measured at the point or place that comes after the word from. All right, so bearing is always measured at the point or the place that comes after the word from. So notice here, notice this statement. The bearing of church A from the bearing of church B from church A. So notice we're going to take the measurement at church A. That's where we're going to do the measurement from, because church A comes after the word from. So the word from right here. So church A is where the measurement is going to take place. Now, notice, if I'm at church A and I need to look at church B, I have to turn my head all the way around. So when Amber says that the bearing is 25 degrees, Amber is incorrect, because Amber would not have used a bearing measurement, because the bearing must be measured from the north in a clockwise direction. Explain why Amber is wrong. So Amber did not use a bearing measure because the bearing must be measured from the north and in a clockwise direction. Right? Calculate the correct bearing of church B from church A. Now, think about this. If you're at A and you make one full turn, what angle is formed when you make one full turn? When you make one full spin, you spin around or make one full turn, what angle is formed? Anybody can answer me. You spin around, you make one revolution. What angle is formed when you spin around, make one full turn? Come on, guys, help me out now. So one full turn or revolution is equal to 360 degrees. So if we should make one full turn at A, we'd get 360 degrees, but we're not making one full turn because part of the turn was already noted to be 25. So the remainder is going to be 360 minus 25. So the bearing of church B from A, well, church A, is going to be equal to 360 minus 25 degrees, which is going to give us 335 degrees. Now notice this is 3 digits. All right, 3 digits. So that's the bearing. Calculate the bearing of church A from church B. So it's church A, so the measurement. This is where we're going to take the measurement from, church B, because church B comes after the word from. All right. So I'm going to go straight to B and my bearings. I'm going to take the measurement from here. So the bearing must be like this. So if I am at B, what angle do I need to turn my head until I'm looking at A? So that's what we are talking about. So I'm at B because the bearing is being measured from B. So I'm at B. What angle do I need to turn my head until I'm looking at A? Now, one of the things that we need to know about these two angles, say that this is angle X and this is angle Y. Angle X plus Y is equal to 180 degrees. They are called co-interior angles. All right, so they're equal to 180 degrees. So I know this one to be 25 because both of them are on the inside. All right, so notice they are both on the inside. So one is here on the inside. So they are co-interior angles. So one is going to be, so the bearing of church A from church B is equal to 180 minus 25. Because remember, both of them, both angles on the inside, this one and this one, must add up to 180 degrees. So if I know the first one, all I need to do is subtract it from 180, and then I will get the next one. All right. All right, let's look at this one. It says the diagram show part of a map. You have tower and you have the church. Find by measurement. Well, this one says by measurement the bearing of the tower from the church. All right, because we don't physically have the paper in hand, we're going to skip this one because it says by measurement. So what you would have to do is to use your pen and pencil to draw a line, straight line between them, and then use your protractor to measure the angle to get the bearing. But since we don't have that, we're not going to. This one as well, this one is by measurement. So these ones that are by measurement, we're not going to be able to do because we don't have the paper physically in hand. So all of the ones that is by measurement, we're going to have to. So by measurement, so we're going to skip past that one. All right. It says the bearing of a ship from a lighthouse is 0.55 degrees or 55 degrees. Work out the bearing of the lighthouse from the ship. Now, there is something that is called back bearing. So let me show you how back bearing work. All right. So it's just as I use the example earlier. Say me. Let's just use two dots, me and you. So it back bearing only works between 2 points, which means the same 2 points, right? So like two people looking at each other. All right, so let's look at this one. If I am looking at you and my angle is the bearing, let's say the bearing is less than 180 degrees, but greater than 0 degrees, right? So the bearing is less than 180 degrees, but greater than 0 degrees. So that is this bearing right here. So, right? So let's say for argument's sake, it is, say, 120. Now the back bearing, if you want to get the back bearing means, so if I'm looking at you, back bearing means you now looking at me. Since the bearing is greater than 0 but less than 180, if you want to get the back bearing, you have to add this bearing to 180 to get the back bearing. Look at this. From this diagram, this angle and this one on the inside, both on the inside must add up to 180. So that means this must be 60. Right? Must be 60. That means all the way around here must be 300. Why do we say it must be 300? Because one full turn at U must give you 360 degrees. So we know 60 of it already. So that means the remainder must be 300. Do you recognize that based on back bearing, the first bearing, because it is greater than 0 but less than 180, if we add 120 to 180, we get 300 degrees, which is you looking back at me. So that is how back bearing work. So if the first bearing, me looking at you, is less than 180, to get the back bearing, all you have to do is add 180. All right, so that is how back bearing work. Now let's look at a different example. So this is you and me. Oh, we always put the north sign, all right? I think I did. I never write the north sign. You have to always identify the north sign. Same thing. I'm looking at you. And say, for instance, this bearing was given to be, say, 295. So I'm looking at you. I'm standing up here. I say, hey, what's up? And I'm looking over at you. But remember, I can't just turn my head to the left because you have the right and you have the left side. I can't turn my head to the left to look at you because that's not a bearing. That's an angle, but it's not a bearing. A bearing must be measured from the north line in a clockwise direction. So if I just turn my head to look over on you, I'm in the wrong. That's not a bearing. So I'm here looking at you. I have to turn my head to the right all the way around until I'm looking at you. Now, if the first bearing is greater, right? So if the bearing is greater than 180, but less than 360, right? So it's greater than 180, but less than 360, you have to subtract 180. So the first bearing is 295. So I have to subtract 180. So that is how you would get the back bearing. All right. So this is going to give you 115. So what does this 115 means? If you are to look back at me, this bearing would be 115. How do we know this? This angle right here would be 65. All right. So this angle here would be 65. Because one full turn where I'm at is going to give me 360. So the remainder must be 65. 65 plus 295, that's 300. This one and this one must add up to 180. So you notice that we can use the calculation with the co-interior angles to get it, or we can use back bearing to get it. So let's look at how back bearing work. Back bearing works between 2 points. You looking at somebody and the same somebody looking back at you. So if the first bearing is less than 180, you have to add 180. If it is greater than 180, you have to subtract 180. That's how you get the back bearing. So when it says you have a ship and a lighthouse, so let's look at it. So let's say ship, you find the north of the ship. Because remember, you know, let's we are not mindful of our compass rule. I think I maybe have taken it for granted that we know. So it's the north, the east, the south, and the west. So we start at 0 degrees. And when we come back around, we come back to 360. We go to 90, 180, 270, and then all the way back around to 360. So if we say that the bearing is 0, 55, which is 55 degrees, it means that if this is my east, which is 90 or 0, 90, then 55 is going to be somewhere in here to the lighthouse. So this is where the bearing would be. All right. Now it says work out the bearing of the lighthouse from the ship. Wait, no, the bearing of a ship from a lighthouse. You have them in the wrong place. So this is the ship, this is the lighthouse. So notice it says it is from a lighthouse. So the measurement is from the lighthouse. So if you are now at the lighthouse and you need to look back at the ship, you're going to look all the way around in this direction. So because your first bearing is less than 180, right? To get the back bearing, it's going to be 180 plus 55. So the bearing of the lighthouse from the ship is going to be 055 plus 180, which is going to be equal to 235 degrees. So that's going to be the bearing of the lighthouse taking the measurement from the ship. So that is how back bearing works. All right, so bear that in mind, please. That's how you would use back bearing. All right, give you a bit to take that off and then we look at some more questions. All right, let's continue. Diagram, measure the bearing. All right, so the fact that even though there are additional parts of the question, the first part, which indicates that we are to measure, if we can't measure it accurately, then everything else is going to be affected in the question. So that's why we don't even continue or consider the other parts of the question. The diagram shows 2 points, S and T. The bearing of T from S is 43. Work out the bearing of S from T. Again, back bearing. So the first bearing given is less than 180. So we need this bearing right here. So the bearing of S from T is going to be 0.43 degrees plus 180, which is going to be equal to 223 degrees. Another way of doing it, we could gone ahead and found this angle right here, because remember, both angles together on the inside must add up to give us 180. So that means this is going to be 137. And we could have said 360, which is the one full turn at T, minus 137, which would give us the same thing right here. All right, so either way, either this way or that way, we would still end up with the 223 degrees. Let's continue in the interest of time, because as I mentioned, I really want to do both. Well, we have done the angles of elevation and depression. We did the sine and cosine rule, so we definitely want to do some work on the bearings. This one asks us to measure. No. All right, let's complete the diagram. Well, that doesn't look so straight. Let me see if I can do it a little better. Well, as best as I can. Church C is on a bearing of 130 from church A. So this bearing here is 130. Church C is on a bearing of, where is he? Oh, wait a second. Church C is on a bearing of 130. Oh, so we must put in, the diagram shows the position of two churches. Oh, A and B. Church C is on a bearing of, okay, let's go. So church C is going to be somewhere down here, because it says church C is on a bearing of 130 from A, and church C is on a bearing of 245 from B. So 245 is going to get us all the way around here. In the space above, draw an accurate diagram to show the position of church C. Make the position of church C with our X, okay. With an X, label it C, all right. That's it, no calculation. All right, that's it, no calculation. Question number 9. The diagram shows point A and B on a map. The point C is due east of A. So notice it says the point C is due east of A. So it would be along the east line. So somewhere along the east line would be point C. It says C is on a bearing of, the bearing of C from B is 235. That's crazy. The point C is due. Oh, Hold on. Where me see east? The point C. Where we see east a while ago? I sure me read something about east. And I south it say. I could know me say east a while ago. But anyways, it says 235. So I'm gonna put it at about here. And it says it is due south. So it is going to be somewhere down here because it is due south. So south means it's south, right? It's not due southeast, southwest, it's due south, all right? The bearing of point D from B is 168. From B is 168. So point D is going to be somewhere down here. So if it is 168. So this bearing is going to be 168. So somewhere down here, we have 168. It's not exactly 180, but 168. All right, so that's where B is. Find the bearing of B from B. Wait, I'm getting this mixed up. All right, let me recheck that one. The bearing of D. Oh, so why did I label it just B out? Oh, I'd label it B. All right, so I labeled it a while ago, so it should be D. So I say, wait, so I'll get 2B. All right, so now it says find the bearing of B from D. So we want the bearing of B from D. So we must know the north of D. Once you're going to leave a point, you must know the north of the points. So we need this bearing right here. So remember, your first bearing is less than 180, so you have to add 180. So the bearing of B from D is going to be 168 plus 180. So once the first bearing is less than 180, you have to add 180. So that bearing is going to be equal to 348 degrees. Okay. So the bearing is less than 180, add 180. If it is greater than 180, you subtract 180. All right, let's continue. All right, this is back bearing. Manchester Airport is on a bearing of 330 from London Airport. Find the bearing of London Airport from Manchester Airport. So again, in this case, because the first bearing is greater than 180, you have to subtract 180. So this bearing is going to be equal to 150. All right, so that's the bearing. So because it is greater than 180, you have to subtract 180. Now, please note, if you were to do your calculation and you get a 2-digit number, all you have to do is write 0 at the front. All right. So if you notice some of the 2-digit bearing that they gave us, let me see if I can show you. So like right here, so notice it's a 2-digit number, but to make sure that the bearing is written with 3 digits, you put 0 at the front. All right. So the bearing is always 3 digits. If you get a decimal number, you have to round it off to make sure that it's a 3-digit number. All right. So it can't be like 123.4, and that's the bearing. Now you have 4 digits. So this is a no-no. All right. So you have to round it off. All right. So here we are given that the diagram shows the position of a yacht Y, a ship S, and a beacon at B. The bearing of B from Y. So notice B from Y, all of this bearing is 228. Find the bearing of Y from B. So you want this bearing. So because it is greater than 180, you're going to subtract 180. So you're going to get 48. So that's the angle. So the bearing is going to be 228 minus 180, which is going to be equal to 0.48. So you have to write it as a 3-digit number. All right, so it's 0.48. One of the ways you could have done it as well is to calculate the angle, calculate this angle, which is going to give you 132. And remember, this angle and this angle must add up to give you 180 because they are both on the inside, on the same side, so they are co-interior angles. All right, so you know 2 ways in which you can work it out. The bearing of S from Y is 118. So S from Y, so this is 118. All right. Find the size of the angle BYS. So you're going from B to Y to S. So that means you need this angle right here. So we have 118, we have 132, so we need the remaining angle right here. So that means X is going to be equal to 110 degrees. All right. So BYS is going to be equal to 360 minus 132 plus 118. So it is going to give us 110 degrees. So remember, them tell us the bearing from the bearing of S from Y is 118. We did already calculate this angle to be 132. When you add a full turn at Y, you're going to get 360. But this is 132 and 118, so the remainder must be 110 in order to get a full angle of 360 degrees. Given also that BY is equal to SY, so that's the length. So they're telling us that the lengths are equal. Find the bearing of S from B. Come on. So it is telling us that the lengths are the same, but we never get any lengths. So it is saying that this side and this side is the same length. So we have an isosceles triangle. All right. So if they are the same length, then that means we have an isosceles triangle. So that means these two angles must be equal. So the remaining angle to get to 180, sum of angles in a triangle is 180. So that means this must be 35 degrees and this must be 35 degrees. So notice we want to calculate the bearing of S from B. So the measurement is going to be taken at B. So when we measure all of this length, which is the bearing, if I'm at B, I need to turn my head to look at S. It is both of these angles combined together. That is going to give me the bearing of S from B. It's going to be equal to 0.48 plus the 35 degrees, which is going to give me 0.83 degrees. All right. So again, we know that these two angles are 35 degrees because if you're working with an isosceles triangle, two of the lengths are equal and two of the angles are equal. All right, so that's how we get that. All right, let's look at this. The diagram shows the position of 3 points, A, B, and C on a map. It says the bearing of A, so the bearing of B from A is 0.70. All right, so that's that bearing right there. So that means this angle right here is 110 degrees. All of this must add up to 360. So you have 160 already, so the remainder is 200. All right. So right then and there, you know, you can see some of the calculations very easy. It says angle ABC is 50 and AB, which is this length, and CB, which is this length, are equal, right? So that means the remainder is going to be 130, and the 130 must be split between the two angles. So that means this angle must be equal to 65, and this angle must be equal to 65 because it's an isosceles triangle again. All right, it says work out the bearing of C from A. So C from A, which is measuring from the north in a clockwise direction all the way down to this line. So if I am at A, how far do I need to turn my head so that I'm looking at C? So that is what they're asking. So that's going to be equal to 0.70 plus the 65 degrees, which is going to be equal to 135 degrees. So that's going to be the bearing of C from A. So the measurement is taking place at A because A comes after the word from. All right, that's it for that question. All right, so not a lot in terms of things to do. So I'm happy to see that that is what we have. All right, still pushing on because I want to see as much. I want to work through as many of the questions as I possibly can. So this will be provided to you as well, so you can have access to it. The diagram shows the positions of 3 turbines, A, B, and C. We have a right angle, so we know we have a right angle triangle. So this side has to be the hypotenuse. It says A is 6 kilometers due north of turbine B. C is 4.5 kilometers due east of turbine B. Calculate the distance AC. So the hypotenuse AC is equal to 6 squared plus 4.5 squared. We're using Pythagoras' theorem. So we're taking the square root of both sides. So the square root of 56.25. So that means AC is approximately equal to, well, it is 7.5. It's 7.5. All right, so we just get the value. Calculate the bearing of C from A. So the bearing of C from A. So we need this bearing right here. All right. So notice there's a C from A. Now, we know that all the way to this line is 180. So one of the things that we would have to do first is to find out what is this angle. So you have this, which is the opposite side. You have the adjacent side. And you have the hypotenuse. So we know the length of the hypotenuse now, which is AC. So you can use any one of the trig ratios. So I'm going to use sine of the angle. Let's call this angle X is equal to the opposite side, which is 4.5 divided by the hypotenuse, 7.5. So X is going to be equal to sine inverse of 4.5 divided by 7.5. So X is equal to sine inverse of 4.5 over 7.5. So we're going to get approximately 36.9 degrees. So that's this angle right here. So the bearing is going to be 180 plus this angle, because all the way right here is 180 degrees. And then when you add the x to it, you get the full bearing. So the bearing is going to be equal to 180 degrees plus 36.9 degrees. So notice here, so now look at this. We're going to get 200, let me write that properly, 216.9. That's 4 digits. So the 9 will round up. So what we're going to get is that the bearing is 217 degrees. So that's going to be your bearings. All right. So remember, once you have the decimal, you round off, whether it's a round up or it's just it don't, it just round it off. All right. Now, some of the questions can be such, well, this look like one of them, that you have to use the sine or the cosine rule. All right. This one look like it is such. Let's see what we're working with. The bearing of B from A is 0.62 degrees. C is due south of B. So that means all along right here is 180, because it says it is due south. So it's 180, not southwest, not southeast. This one right here is going to be 118, because this plus this must give you 180. All right, so it could be, we could easily find what X is, but let's see what they say. Find the size of angle X. All right. Find the size of angle X. Angle X is going to be equal to 360 minus 118 plus 180. All right. So that's the size of that angle. That means that this angle is 59 degrees. This angle is 59 degrees. So if this angle is equal to 62. Mhm. Give a reason for your answer. Well, why a reason? Now we do a calculation. Oh, I see why they want a reason. All right, so alternate angles just simply means Z angles. So this angle A must be equal to this angle A. So these are alternate angles. Now, the Z doesn't change, it doesn't matter what form it is. So if we go down like this, come up and then down. So notice this angle is 62 degrees. So angle X right here must also be 62 degrees. All right, so even though the orientation of the Z changes, it's still a Z. All right, so that's the reason why they're saying they want a reason. So they are alternate angles. Okay. Work out the bearing of C from A. So it is C from A. All right, so we already work it out. So if I am at A, how far do I need to turn my head so that I'm looking at C? So C from A is going to be equal to 62 degrees plus 59 degrees. All right, 121 degrees. All right, so that's what we would end up with for the bearings. All right, let me see if there is any more difficult questions. All right, I'm going to do number 20 and 21. Oh, all right, so I'm going to do 20 and 21 and wrap up with you guys for today. What we can do is that some of the other questions, you can just take a look at them and work through a few to so that you get a bit of practice for yourself. The diagram shows the position of three buildings in a town. The bearing of the church from the school is 056 degrees. The hospital is due east of the church. The distance from the church to the school is equal to the distance from the church to the hospital. Work out the bearing of the school from the hospital. So the bearing of the school from the hospital. So we need all of this. All right, so we need all of this length. Now, this is going to be 90 degrees as well, because this line is a horizontal line and it is due east. So this is 90 degrees. So all of this is 270. But notice it does not look like 270, right? Doesn't look like it, but it is. All right. So wait. Oh no, it doesn't come back all the way around to that line. Mercy. When I draw it a while ago, I think I all in my mind say I draw it right back around to this line. Sorry about that. All right, so let us see what we're working with. Now, if this is 56, then that means this angle right here is going to be 124. 124 plus 56, that's going to give you 180. So 124 plus the 90
So that means all of this angle right here is going to be 146. But bear in mind, it is isosceles. How we know this? Because it says this length and this length is equal. So that means these two angles have to have the same magnitude, right? So that means this angle is going to be equal to 17 degrees. Likewise, this angle is 17 degrees. So the 90 plus the 17 minus from 360. So you'd have 360 minus 117. No, 107 is going to be equal to 253 degrees. So this would be the bearing of the school from the hospital. All right. Because this is an isosceles triangle, these two angles are going to be equal in magnitude. That's all they ask us for. Yes, that's all they ask us for. Number 21, it says there is a Coast Guard station at point A, and at point B, B is due east of A. All right. So if it is due east of A, then that's on a 90 degrees. The distance from A to B is 12 kilometers. Okay. There is a rowing boat at point R. R is on a bearing of 160 from A and a bearing of 220 from B. There is a speedboat at point T. T is 5 kilometers due south of A. Okay. Work out the shortest distance from T to R. So the shortest distance from T to R is a straight line. So we want to know that distance right there. Okay. Give your answer to one decimal place. You must show all your working. All right. Oh, that's the only calculation. All right. If all the way to down here is 160, then that means this angle is 20 degrees, right? If this is 90 and all the way to here is 160, that means so right at this angle right here, that's going to be 70 degrees. Right, so that's 70 degrees. This angle is 90 because it is due east. So this angle is 50 degrees. So that means this angle right here and 70 is 12, 60 degrees. All right. So you might be asking why I'm doing all of that, because we know that from A to T is 5. We can find this length, and if we know this length, we can find this one right here. So that's why it says to show all your working. So that's why we're doing that. So over here is lowercase b, over this side is lowercase a, over this side is lowercase r. So what you're going to have, a over the sine of a equal to b over the sine of b equal to r over the sine of r. Now, we don't need to find a, which is all the way over here, so we don't need this fraction. We're going to use this one. So we're going to have b times sine 60 equal to 12 times sine 50. Divide by sine 60, divide by sine 60. These go. And then we need to work out over this side. So B is going to be equal to 12 times the sine of 50, sine 50 divided by sine 60. So we end up with 10.6, 10.61. That's the length of B. All right. So we know the length of B. Now, this is going to be two sides and the angle between, so we can find this side over here. All right. So let's call this side X for right now. Once you have a triangle and you have two sides, you have this side, the angle, which is 20, and then this side, you can use the cosine rule to find the side which is opposite. So we're going to have x squared is equal to all right, so that is how you'd go about finding the distance from T to R, using the different rules, the sine and the cosine rule. All right. So bear in mind that the calculation can be such that it can ask you a question that requires you to use the sine rule, the cosine rule, the trig ratios, and Pythagoras' theorem because you're working with a triangle. All right. Any questions before we close off for today? As we did with module with unit 1, we just look for the assignments to come to you with the in the teams so that you can know what you have to work on. All right.
Yes, sir.
Yeah, man. All right. Take care of yourself until we meet again. Yeah.
All right, sir. Sir, we are walk, sir. We just leave school. Walk out of school.
All right then.
Yes, sir.
Yeah, man. Take care.
Yeah, man. Now look at it.
Yeah, man.